All right, here's the equation that we have. We can do this in three different ways. One way is so the answer to the question is solve this. And when they say solve this, they basically mean find the x-intercepts. There's three different ways. The first way is called the quadratic equation. And the quadratic equation is this long, painful thing that is just, it's annoying and tedious, but it's not hard to do. And it gives you the right answer, and you can memorize the formula. So you can plug the quadratic equation into there. Any questions about how to do that? No. Okay, good. The next way is straight up factoring it. I call that my fly swatter. Remember, I need to kill this beast, and I could use a bazooka, or if it's a small little beast, I could use a fly swatter. The fly swatter is real quick, it's easy, it's elegant, it's clean, it's cute, and all of that kind of stuff. But it only works if this thing can be factored. The bazooka always works. It's painful, it takes a long time, but it always works. The fly swatter, cute and easy. It's way quicker than the bazooka, but it doesn't always work. You kind of have to see the pattern if it does. Here's the other thing. This is basically, the third technique is called complete the square. And complete the square is like the precursor to the bazooka. In fact, the bazooka, the quadratic equation, is basically, what you're doing is you're completing the square real quick right off the bat. So I'm going to show you how to complete the square. And it's kind of like, I guess, going back to our analogy, completing the square is like all the tools you need to build a bazooka. Okay? So you can kill the fly in three ways. You can use a fly swatter, you could use a bazooka, or you could build a bazooka yourself and then use the bazooka. Cool? All right. One more point is, does that mean that completing the square is not useful because we already have the quadratic equation? And my answer is this. Completing the square is extremely useful, especially if they say graph this. Okay? Because when we graph this, it's always easy to graph if we have something like this. Right? Like if I ask you to graph this, this is cake for you. If I ask you to graph this, that's hard to do. Okay? Well, in order to make this thing into this thing, because this is called standard form and this is called vertex form, in order to turn this to here, you need that complete the square thing. So yeah, if you want to solve an equation, complete the square isn't very useful. But if you want to turn it into a different form so that way you can see things, that's when complete the square comes into play. Anyway, let me show you the whole game that we play. You ready? What we do is, first thing we do is we don't ever like a number in front of the a term. So I'm going to divide everything by 2. Because if I divide this by 2 and 2 and 2 and 2, that basically makes this thing a 1 in front of the a term. We cool? So this is 2 times x squared minus 5 over 2x plus 6 equals 0. Sophia, you asked me that question before, and my answer is this. Because for this specific trick that we're going to do, we need the a term to not have a number in front of it. Okay? All right. Yes, Madison, I could put 2.5, but actually there's a reason why I don't do decimals in this particular case. Okay? The next thing you do is you take this b term, you divide it by 2, and then you square it. So this b term is negative 5 halves divided by 2
So I should just put an arrow. So that would be negative 5/4.
And then you square it.
So that would be positive 25/16.
Okay? Notice how I put a big space in between here. The reason being is because you're going to take this magic number 25/16, you're going to add it and subtract it in here.
Let me just write that down. 2x squared minus 5 halves x plus 25/16 minus 25/16 plus 6 equals 0.
Did I lose anybody? Do you understand why I added and subtracted at the same time? Sophia, I agree with you. What you're saying is, don't you add it to this side and that side at the same time? We could do that. One direction is to do it that way. The other direction is to do it this way. But really, you're doing the same thing. Let me answer Sophia's question real quick. If I have a number like 6, okay, equals a or something like that, I could do this, plus 3 over here, right? Because if 6 equals a, then 6 plus 3 is equal to a plus 3. We cool? But I could also do it like this. I just move this 3 over to that side, and it's just a plus 3 minus 3. Because plus 3 minus 3 is 0, so it's really just saying 6 equals a. You get it? And Sophia, I would say that in this particular case, it'd be a little bit dangerous if I do plus 25/16 and I put a plus 25/16 on that side. And the reason being is because of this 2 out here. It kind of plays a special role. Okay? All right, anyway. See these 3 numbers? This thing becomes x minus 5/4 squared. And that comes back to that formula I had you memorize. A plus b squared is equal to a squared plus 2ab plus b squared. Look, this right here is double that number right there. And this number right here is that squared. You see it? So I basically have this, and I say, oh, then I can basically turn it into this. Look, if you don't believe me, FOIL that out, and I guarantee you, you're going to get what I double underlined. Cool? How is negative 5/4 times, or doubled 5 halves? Well, negative 5/4 times 2 is negative 5/2. Maybe you might want me to do that? Okay. And then negative 5/4 squared is 25/16. We cool? Right, because negative 5/4 times negative 5/4 is positive 25/16. So that's what that is. Then you still got to deal with this junk over here. Minus 25/16 plus 6. And Madison, by the way, do you see why I didn't turn this into a decimal? It's because dividing this by 2 and then squaring it, if this were 2.5, and then I divide that by 2, that would be like 1.25, and then what's that squared? It just becomes more confusing. All right, where did the 2 go? Oh, I'm sorry, you're right. The 2 is still there. All right. At this point, you have to combine these fractions. You guys know how to do that. I'm going to cheat. Negative 25 divided by 16 plus 6. All right. Is 71 over 16. So this is, can I just erase this and put 71 over 16? Are we cool? So let me multiply that 2 back in there. So I have 2 times x minus 5 fourths squared plus 71 over 8 equals 0. Okay. So look, we've changed it into vertex form. And, well, 71 over 16 multiplied by 2 is 71 over 8. Yes, I agree with you. It's so ugly. Remember, I made this problem up off the top of my head. I didn't expect the numbers to come out nicely. Anyway, if you solve for x, in this case, like we haven't even finished solving for x, but it's actually really easy. Wait a second. It looks to me like you can't solve for x. Let me double check something. Well, no, the reason why you can't is because when you take that or 71 over 8 to the other side, it becomes negative 71 over 8. Then you divide that by 2 and you square root it, you're taking the square root of a negative number. Let me just double check to make sure I did right. 6 minus 25 over 16. Yeah. Let me graph this on Desmos and see what they say. Two x squared minus 5x plus 12. 2x squared minus 5x plus 12. Oh, yeah. If you plug this into Desmos, you'll find that the answer is this. So I screwed up because, well, I didn't screw up, but I mean, I'm asking when does it cross the x-axis? It never crosses the x-axis. That's why we get an imaginary number over here. We cool? All right. Yeah, no, I mean, I could have probably made a better problem if I like had time to work it out, but I mean, you wanted me to make one off the top of my head and show you all the steps to completing the square. A quick point is, if this were equal to 0 and it says equals 0, then literally just, if this were equal to 0, then literally use the quadratic equation and don't mess with it. Like, don't even try it. Just quadratic equation, sucker. It should do it. But if this were equal to y, and Sophia was asking, why are you only messing with the left-hand side? And I'll tell you why. Because in trying to turn this into vertex form, that's why I was messing with only one side. Because I didn't want to mess with the y on that side. So I would do all these tricks where instead of adding 25 over 16 to both sides, I added 25, 16, and minus 25 over 16 to the same side. Well, again, some questions want it into complete the square form. Yeah. Some questions specifically want you to put it in vertex form. But you want to know my honest answer? Here's what I would do. if I got this problem right here, if I got that problem and they said, here's an equation in standard form, give it to me in vertex form, here's the options I would do, okay? I would take a look at all of the answers, because all of their answers are going to be looking something like this. I would FOIL out all of their answers, and I would see which one matches that one. All right? Well, Mr. Dalday, what if it's not a multiple choice test? What if they just say, here's the thing, and then they ask me to type in my answer? Okay? Then here's what I would do. Okay? I would graph that using a graphing calculator. And from that, I can estimate the x and y intercepts. And I can just, or the x and y coordinates of the vertex and plug them in there. Now, in this particular problem, that's a little bit hard to do. But if these numbers come out nicely, you know, like 2 and 5 or something like that, it's easier to do on the graphing calculator, and you can just cheat that way. That's what I would do. And as a last resort, I mean, maybe since I'm good at math, I'll do complete the square, but as a last resort, I'd use complete the square. It really isn't as, I don't want to say it's not as useful. It might not be as like this super huge technique that you need to make sure that you've got. Although, who knows? Maybe they could come up with a question where it's like complete the square, and then you'll be like, Mr. Daldy, you're wrong. Yeah. All right. Anyway, I gotta go too. I told you I was finished at 2:40. I've recorded a lot of videos. I'm gonna upload